Hi, hello everyone. Thank you for being here today. We'll wait 2 minutes to start the webinar. Okay, for those who still are who are still joining the webinar. So yeah, let's wait a few minutes and let's start with the session. Okay, so let's start with the webinar today. Thank you for being here. The session will be about AC-coupled battery energy storage system, hybridizing your PV plant. So first, let me introduce myself. I'm Irene Negro. I'm a customer success manager at RatedPower. I work for the support technical support team, focused mainly on the Spanish and the Latin markets. And also focused on the battery projects within the software. I'll be talking about that later. So this will be the agenda for today. For today's webinar, we'll be introducing the AC coupled systems, the different battery technologies. Also, we'll be focusing on the AC coupled systems, the advantages and disadvantages. Then we'll go through the automatization or the automation of the basic engineering of the battery system. We'll do a case study in pvDesign, the software developed by RatedPower. Then we'll see the results also provided by software, the future developments, and then we'll have like 15 minutes of the Q&A question session. Okay, so let's start. But first, let me talk to you about Pulse. This is a global renewable and energy transition event that will be taking place in Madrid during the 19th and 20th of April this year. So so yeah, you'll have the opportunity to talk with different PV experts and experts from the industry. So we'll be also handling different workshops and different talks. So if you have the chance, I encourage you to come to Pulse. It will be a really good event. So after saying this, let's start with the session. First, let me introduce RatedPower for you who doesn't know about the company and about the software. RatedPower is a company based in Madrid. We developed software as a service called pvDesign that will help you developing, designing, and optimizing PV plants. So through pvDesign today, we'll be designing our battery system. We'll be including the battery system in our plant. So this is why this webinar is focused on that. So just to introduce you our software pvDesign for you to have an idea of what we do regarding the users that we have now, the customers, how many watts they have been simulating during this year. Okay, so let's start with the session and with let's start talking about batteries, about AC coupled systems. So basically, to introduce these kind of systems, the AC coupled systems, the main idea of these systems is that they use different inverters from the one that that we find in our plants. Okay, so when talking about hybridizing PV plants, the AC coupled systems use different or separate inverters, right? So that's why we find they have some advantages with regards to other systems, such as the DC coupled or even the standalone systems. Okay, so this is the main idea, that they don't share inverters with the ones that we have for our panels or our PV panels. Okay, so let's continue with the different technologies that we find in the market regarding the battery system, the main technologies, of course. So we have AC coupling, DC couple, and standalone systems. So although we will be focusing on the AC coupling, let's just set the main differences between these three different technologies. The AC couple systems, as I was saying before, they are connected or they are using separate inverters from the one that the solar panels are using. Okay, then we have the DC couple systems that they are usually allocated next to the PV panels, so inside the PV plant, and they are sharing usually the same inverter. And finally, we have the standalone system, which are like different, like sorry, I think you are, let me see. Okay, yeah, basically the standalone systems are systems that are separate batteries, that they are not connected to any renewable source such as wind or solar. Okay, so let's focus also on the application of the AC coupled systems. Okay, there are different applications that make this system interesting now in the industry. Like for example, they can support the grid, so grid ancillary services such as frequency regulation, black start capabilities, voltage support. So basically, they can support the grid. As we know, the solar systems, they are not they are intermittent systems, so that's why we need, or we would be needing, AC coupled systems. We can also use these systems for energy arbitrage, load management, transmission resource management, and also microgrids. Okay, and finally, let's have a look at the let's see if I can, okay, here the advantages and disadvantages of the AC coupled systems. Okay, so the benefits, comparing them with DC coupled or standalones, are retrofitting, flexibility, resiliencies, versatility. These are all related to that they are using different inverters. So retrofitting, for example, it means that we can allocate the system outside the PV plant. So for existing plants, they would be good. The flexibility means that as they are using different inverters, we can discharge at full time or charge at full time both systems at the same time, the plant and the system. And regarding, for example, the watch outs or the disadvantages, one would be the cost. We are using different equipment, so they are not sharing inverters. Lower efficiencies. This is because we have to convert the current 3 times instead of 1 with the DC coupled BESS. Supply limitations regarding the transformer list of these systems. Okay, so let's continue that we have talked about the AC coupled system, and let's see an example in pvDesign. Okay, so let me just stop sharing my screen for a moment. Okay, and let me go inside pvDesign so we can see the case study. And okay, okay, just a moment. Let's go inside pvDesign and let's see the case study that we have prepared for this session. Okay, so let me share my screen again here. Okay, I guess you can see my screen now again. So let me introduce you for those doesn't know pvDesign, our software. Basically, as I was saying at the beginning of the session, pvDesign is a cloud-based software, so you just need to have access to the internet to access the software. Here we would have the main page of the software with the different projects, and here what we would do is to look for a specific project to do that case study. So let's look for this project in Atacama Desert in Chile, and let's work on a design to introduce or to include our battery system in the PV plant, to hybridize our plant, for you to see how to do it in the software. Okay, so as you can see here in the project, we have different designs. So let's, for example, take this design as an example. Let's clone it. So what we will do now is to go through the design process of the software that will allow us to define the different parameters of our PV plant. And as you can see here, there is a specific tab, which is called the BESS tab, the Battery Energy Storage System tab, which will be the tab where we will be focusing today, okay, to include that battery system. But just for you to have an overview or a general idea of the software, for you who doesn't know this software, basically this design process that will allow us to design our plant. It is composed by 9 different tabs, okay, location, equipment, layout, and we will be able to include or to define the different equipment that we would like to use, the layout or civil parameters, the electrical parameters. So here, for example, in equipment, we would be selecting the equipment that we would like to consider. In layout, as I was saying, we would be defining those civil parameters of our plant, such as the GCR or the pitch distance. Then we can also include topography analysis for the PV plant that we are evaluating. Then we have the grid point and electrical that will allow us to include all the electrical parameters and cable sizing. And then this is what it is the most interesting tab for today, the battery energy storage system tab. Okay, so as you can see here, as part of the layout where I have included the my PV plant, I have also included the step-up substation. I have included an extra area which is called the battery area. So in this area here is where I'm going to include my AC-coupled system. This is important. This is why this webinar was focused on AC-coupled systems, because for now in pvDesign, was what you can include to hybridize your PV plant is an AC coupled system. This is why this system is outside both the PV plant and the step-up substation, and it's close to the step-up substation to save or to decrease the MV or the medium voltage cable lengths. Okay, so let's see how we can work with this battery system, or how we can include that system in our plant. So basically, as you can see here, inside the tab, we have 4 different sections: power conversion system, a battery container, the requirements, and the layout. This will help us to define the different parameters, and it will help the software to include our battery system in the plant. Okay, so you can see here, the summary of our plant is we have a plant of about 146 megawatts DC, 122 megawatts AC. So based on that, based on the capacity installed in in our plant, we will size our battery system. So the first step here on the power conversion system will be to define the power of our PCS, or power conversion system, which is this green square here. Okay, so how can we do that? We can select the specific storage inverter that we would like to use for our battery system. So if I click here and change inverter, I will access the database where I can select the specific inverter that I would like to use. In this case, let's keep this one from Sangro, and we can also set the number of inverters per PCS, or power conversion system. Okay, so it would be this symbol here, these green squares I was saying. So once we have set the power of our block, next step would be to also define the capacity of the battery containers. Okay, so we have two solutions here, two possible solutions. You can set the capacity per container, per complete battery container here. This would be our container, or you could also include that capacity or define that capacity per rack. And then we define the number of racks per container, and that way we would be sizing or defining the capacity of our battery. Okay, so these are the two solutions that we have for now. And once we have defined both the power and the capacity of our battery, the next step would be to specify the capacity of our system, of our battery system. Okay, so we'll have two options. We can ask the software to install the maximum capacity in that area that we have defined for batteries, or we could also specify the capacity that we would like to include. In this case, as we have a specific size for our PV plant, and we know the specific peak power and the rated power, I think it's better to manually set or to manually specify the capacity of our battery. Okay, so we just need to set the number of PCS, and the software will automatically set the power of our battery system. So it could be a 5% of the total amount of power of our PV plant, a 10% of the capacity, a 15%. That will depend on the size that we want our battery to be, also on the applications. Then we have, as you can see here, also the hours of supply duration. Okay, and depending on the hours of supply duration that we set, we'll have a greater or a lower number of containers. So that way the software will be sizing the battery. And as I was saying, depending of course on the application. For example, if we would like to use this battery system for I don't know, peak shaving, for example, maybe we could set 2 hours of supply duration, 4 hours of supply duration. It will also depend on the grid, on the point of interconnection. So so we have different possibilities, and of course we can set or we can design different battery systems and see which one would be the optimal, okay, for applications, and also depending, of course, on the financials and benefits of that system. Okay, so once we have defined the requirements, for example, I could set here 15 to adapt to the total peak power of my plant, 2 hours of supply duration. And finally, we have some layout parameters, PCS dimensions, battery container dimensions, some distances here that will help the software to allocate the different PCS and the different containers to adjust to the final battery energy storage design. Okay, so this could be the model for batteries within the software. As I was saying, depending on the applications, on how we are going to perform, or how our batteries will perform, we'll be setting those different parameters and the equipment that we would like to use. Okay, so once we have defined our battery system within our plant, so we have our hybridized our system, we can just generate our design within the software, and we'll see now the results that the software will provide. Okay, so let's generate the design. We have different options regarding the languages. Let's generate all the documentation in English this time. Okay, and let's click on generate the design. As I was saying, in today's session, I'm focusing on the battery system and how to include it in our plant. But of course, if anyone is interested in having a look on the rest of the software, you can always contact us. Okay, I'll give you my personal email at the end of the session. You can contact me not only for the software purposes, but also in case you would like to further discuss on this topic, on the AC coupled systems or the battery systems in general. You can always contact me. Okay, so as I was saying, the software will provide us with a list of documentation, with a list of engineering results, okay? And part of those results will be focused on that battery system that we have just included in our plant. So this would be the general layout of our plant, including also the step-up substation. And here's where we can find the final layout of our battery storage system. Okay, so we have our PCS or power conversion systems, we have our containers, and we have the interconnection, and this system is connected to the step-up substation. Okay, so this would be the MV cable. Of course, the software will size that cable and will provide us with the amount or the total cable length. Okay, so let's have a look at the documentation that the software generates, and let's focus on the documentation related to the battery system. Okay, so as you can see here, we have our report, which is the battery energy storage report, where we'll find a summary of our system. We'll have also, well, in the bill of quantities or the bill of materials that the software generate, we'll have an entry specifically for the batteries. So we can see all the quantities regarding the PCS and the containers. And we'll also have the general layout in a PDF or in a DXF file or AutoCAD file. Okay, so this general layout that we are seeing here, it's the one that the software is also providing as part of the documentation. Then we have also the single line diagram of the battery system, and it will be also included in the interconnection facility or the step-up substation single line diagram. Okay, so for example, let's have a look at the single line diagram for the battery system for you to see one of these results. Let's take a look. Okay, so as you can see here, what the software will provide or where the software will size. Let me zoom in a bit more. Okay, it's the battery containers with the capacity that we have set. Also the inverters and the number of inverters. This is also a parameter or an input that the user set or provides. And then we finally have the different transformers, or MV transformers in our system. Okay, so this would be the single line diagram just for our battery system. Okay. Then we would also have, as I was saying, the battery report. We can also take a quick look at that document for you to have an idea of what the software will provide regarding this. So this would be the battery report with the summary of our system with the layout of the system, the location, the main equipment, or of each of the storage inverter, the containers, and all the information regarding the capacity and the power of our system. Okay, so this would be how we could hybridize our system with pvDesign with the software, using the software. Okay, so let's go back to our presentation because I would like to also, okay, let's go back to our presentation here. We have also, okay, we have already seen how we can include our battery system in pvDesign, right? But let's talk now about before the Q&A. Let's talk about future developments. What will be our next steps regarding batteries? It has also it is directly related to the market. And what we think it will be important to have in the future. So for future developments, we are working now on including in the software the DC or a DC coupled battery system. As for now, we understand from the market that the AC-coupled system for what we have seen during the session for the advantages that they present. They have more impact now on the different plants, but we think that DC-coupled systems will be also probably included in the future. So this is why we have thought to include them. It will be the same as what we have seen for AC-coupled systems. So it will be the software will provide the basic engineering of this DC coupled systems, both the design and the basic engineering, just as we have seen for the AC coupled systems. Okay. And this is what will be for now, like the as I was saying, the short-term future developments. We will be also thinking on including maybe an energy model to see how to charge and discharge the battery, to also study battery degradation. This is for the future, because we are now focused on DC coupled systems, but we would also like, of course, to include that in the future, because we understand that batteries and storage system in general are important now, and it's something that we have to take into account as software provider, PV plant software provider. So now let's take these last minutes for this Q&A or the questions or any comments that you would like to share with us. I would like to ask you something here. As you can see, this question. What would you like to see next in pvDesign? As you have seen during the webinar, the session, you can now include AC coupled systems. In the future, hopefully in the near future, you will also be able to include DC coupled systems, but we would like, of course, to hear your feedback and comments and see what do you think, or what do you think it would be important to have as part of this software that helps developing and designing PV plants, and in the future to also hybridize PV plants. Okay, so let me just thank you for being here today, for attending the webinar, and let's start with the questions. Let me just check, because you can write. Let me just check here the different questions. Okay, you have done a lot of questions. Let me just check all of them. Okay, let me start with okay. I'll start with the first one. Okay, so I see here that you say that you ask, can you import from the designs from the platform to KMC Google? Okay, so I don't know if can you import from the designs from the platform? Okay, so basically, when talking about pvDesign, you can for start working with the software. Okay, let me just show you here. Let me just for start working with the software, to include the site that you want to evaluate, you can or you have to import that site in a KML or KMC file from Google Earth. You can also create directly in the software, and then you can export also that file in KML or KMC. Okay, but for start working with the software, to define both the available area for the PV plant and the specific area for batteries, you can define that in a KML KMC file and upload it here to the platform to start working with the software. Okay, so this was regarding the first question. Let's go for the next one. How did you define the size of the battery? Okay, so let me just go back to the battery energy storage system tab. So how can I define the size, right? So as I was saying, first you have to define the power of the PCS, or the power conversion system, by selecting the storage inverter that you would like to consider and the number of inverters for PCS. So for example, in this specific case that we were evaluating, or that we were including in our plant, we selected a 3 megawatts PCS. That would be this this square here, okay? So once we have set our power conversion system, we can also include the capacity of our container, okay, or of our racks. It will depend on the solution that you will be using in the battery, okay. So for example, if we set the capacity per container, we have 3 megawatts container capacity. Okay, so this is why regarding the hours of supply duration, we have 1 hour, 2 hours, 3 hours, because it's directly related with the power and with the capacity of our equipment. Okay, so once we have set both the power and the capacity of our containers, we are sizing our battery system based on the number of the containers that we would like to include and how we size that battery. Basically, it will depend a lot on where we are developing, for example, our battery system. Here in Spain, it could be a 5% of the nominal power or the rated power of the PV plant. That would be, let's say, a proper size for our battery system. So having, for example, this specific size, 122 megawatts AC installed in our plant, we can size our battery based on that, knowing that we would like to install a 5% of that nominal power. So that would be a strategy for sizing our battery system, okay? But this is how we define inside the software. We just have to set the number of PCS, okay? So that way we would be sizing our battery in terms of power. Okay, so let's continue. Okay, next question. Is there a possibility to get an augmentation plan proposed? It is not possible for now because the software is providing the basic engineering of the battery system. So we are not including any degradation model, or so we don't know how the capacity is decreasing throughout the years. We are not. We are providing with the clipping, the energy clipping at the inverter level, so you know the excess energy that you'll have in your plant, but we are not charging or discharging the batteries, or we are not, as I was saying, we haven't implemented yet a degradation model or an energy model to see how, or to see to study the performance of the battery. In the future, of course, this is an idea that we have in mind. So once we develop, as I was saying, hopefully in the future we develop a tool, or we improve this tool that we have now, and we can include that degradation model and that energy model. Maybe we include also that possibility to get an augmentation plan proposed for during the years to see how you can expand the capacity of the battery. Okay. Okay. Let's go for the next question. What is the physical model and dispatching model used to perform energy simulations, including these batteries, or are these not integrated in the simulation yet? Okay, so yeah, as I was saying just in the question that you had before, there's no energy or physical model or dispatching model for the batteries. It's just the basic engineering and the layout, or the design of the battery, but the dispatching model is not yet included. Of course, any suggestion that you have, any comment that you have on that, we'll be happy, or more than happy, to hear your feedback, to have a conversation with you, to see what it would be interesting for you to have. In the end, we would like to include some different dispatch strategies. This is for the future. That's why we are open to hear your comments and your feedback on this. But this is something that we would like to include. So yeah, we would need to study different dispatch strategies depending on the application of the battery, depending if you are using it for I don't know, big shifting, or in case you would be performing the system for grid ancillary services. So depending on that, we would need to study different models and different possibilities to include in the software. Okay, so let's move to the next question here. Okay, so what is the maximum hours the battery can hold power for? So it will depend, that hours, that supply cycle duration, it will depend on the number of containers connected to a specific PCS. So as I was saying here, just to see the example quickly, we have 3 megawatts power PCS, 3 megawatts hour capacity in container. So we'll have different possibilities regarding the hours of supply duration. So the maximum hours that the battery can hold will depend on what we select here on the hours of supply duration, and that will depend on or it is directly related to the number of containers that we connect to a PCS. So in case we would like to increase the maximum hours of supply duration, we would need to increase the number of containers connected to our specific PCS if we have these specific characteristics. Of course, if we have 3 megawatts and 3 kilowatts per hour, we'll have these options. And if we increase, or if we want to increase the hours of supply duration, we need to increase the number of containers in our battery. Okay, so let's continue. Okay, this is also an interesting comment that you have here. Do you imagine to include an optimization feature for the battery sizing, for example, to optimize the whole system based on cost for projects with limited available rated power at point of injection? I think this comment is really interesting, because for now, as you can see, it's a manual tool. You have to set both the capacity and the power and the hours of supply duration. But we would like in the future, or we would need to think about it, of course, but we could think of including that optimization feature that would help you optimizing not only the battery system but also the PV plant. So we could kind of size that battery system for you based on costs, or on that limitation of availability at the interconnection or at the injection point. But yeah, we could think about it, of course. I think it's that's really interesting. It's an interesting point. So yeah, let's think about it. Let's share it with the product team, and let's see if at some point we could include that optimization feature. So let me continue with the next one. What type of battery chemistry is used for this simulation? Okay, this is also a good question, because as you can see here, the inverter is the only specific equipment that we are considering, the storage inverters. Okay, but the rest is generic. So for battery container, it would be like a generic container. Then you can download the documentation and edit it. But inside the tool, the battery would be like a general container, meaning that no chemistry selected. So it could be lithium-ion battery. So it could be the chemistry that you would be considering for your specific system. But as we are not including an energy model yet, we are not selecting that chemistry for the system. Not for now, but hopefully in the future you can select different chemistries within the system. Okay. Okay. The next question is similar to one that I have answered before. But what is the plant life considered for the battery system? Does the battery system include oversized system or augmentation? As I was saying, for now this is not considered, because we are not evaluating that battery system life for degradation. So as we are not considering that, or we have not developed, or we haven't included a model yet, we are not considering that. But hopefully in the future we can consider both that oversize or that augmentation for the system. Okay, sizing, I mean by taking into account the degradation. Okay, okay, because I'm reading the questions that you were doing. Okay, so when you were talking about sizing, you were talking about how we were taking into account the degradation. Yeah, for now, we are not taking the degradation into account. So when we talk about sizing the battery system within the software, it's not like sizing from an energy point of view. It's just to be able to include the design or the layout, the preliminary layout of the battery system within the plant. But we are not sizing the system based on that degradation. Like, okay, from now to 10 years, you'll need to increase your system 10, 20%. We are not doing that for now, but yeah, let's take all these comments as feedback for our product team, because I think they are all interesting, and I see that there are a lot of comments regarding augmentation and oversizing the system. So let's take that into account and into consideration, of course. Okay, let's continue with the rest of the questions. There are 3 minutes left. I think I won't be able to answer all the questions, but please feel free to reach out to me. Okay, so we can keep discussing about the battery systems and the benefits and how we could include different features within within our software. Okay. Okay, so let's go to the next question here. Which brands have already been defined? Okay, so regarding brands, as I was saying, for storage inverters, we have included, well, the inverters that we have for the PV plants. So you have, if you click on change inverter, you'll have different manufacturers, ABB, Sangro, Ingeteam. You'll find the main manufacturers or different manufacturers within the that public database. But regarding battery containers, we don't have any brand or any manufacturer yet. The idea is to include different manufacturers in the future. Okay, but for now we have manufacturers just for the storage inverters. And as I was saying, we have Sangro, Ingeteam, ABB. We have a huge list here. Okay, so let's continue with the next one. How can, this is directly related to the last one. How can we define new batteries in your system? So by new batteries, I guess you're talking about different manufacturers, I guess. So for now, you can just include storage inverters. So you'll have the option to import into the software different storage inverters to use it during the design process. So you can manually do it as a user. Regarding the containers, for now, we don't have any manufacturers, but the idea is that you can also include that new batteries or that new systems manually in the future. Okay. Let's look for yeah, there's a lot of questions here. Let's take but the next question here. Okay. Okay, can the software determine the wall design of the system, including grounding system, civil design of the solar panel structures, etc., for both solar and the BESS or the battery system? Okay, this will be the last one. I'm sorry, I know there's a lot of questions. I'll try to contact you via email, okay? But yeah, the software is not only providing with the energy calculations, but also with the grounding system, the civil design, how the structures are installed, how the how the structures are positioned. It will also provide you with topography analysis in case you apply it with all the electrical configuration. So it will go through different parts of the design process. This is for the PV plant. And for the battery system, it will also provide with the bill of quantities of that battery system, and with the medium voltage cables and the equipment needed in order to be able to design or to include that battery system within the plant. And okay, as I was saying, this is the last question. I'm sorry, because I know you have a lot of questions. I would be happy to discuss all of these questions with you. So in case you want to, please feel free to reach out to us, or reach out to me, and we'll keep this discussion about the topic and about batteries. Okay, thank you very much for being here today.